Let us take a look at example 1. Y equals x squared plus 8x minus 2. In this example, 2a is equal to 8. This implies a is equal to 4 and a squared equals 16. We need to add 16 and subtract 16 on the right-hand side of the equation. Note that x squared plus 8x plus 16 is a perfect square, and this can be factored as the quantity x plus 4 to the second power. So, y equals x squared plus 8x minus 2 can be written as y equals the quantity x plus 4 to the second power minus 18. This equation is in vertex form. Note that a is equal to 1, h is equal to negative 4, and k is equal to negative 18. The vertex is the point negative 4, negative 18. Let us try another example. Say y equals x squared minus 10x plus 18. In this example, 2a is equal to negative 10. This implies a equals negative 5 and a squared equals 25. We need to add and subtract 25 on the right-hand side of the equation. Note that x squared minus 10x plus 25 is a perfect square, and this can be factored as the quantity x minus 5 to the second power. So, y equals x squared minus 10x plus 18 can be written as y equals the quantity x minus 5 to the second power minus 7. This equation is again in vertex form. Note that a is equal to 1, h is equal to 5, and k is equal to negative 7. The vertex is the point 5, negative 7. Now, why not factor the given as the quantity x plus 5 to the second power? Applying FOIL method, the quantity x plus 5 to the second power is equal to x squared plus 10x plus 25. Note that the second term is 10x and not negative 10x. Now, let us consider a more complicated example of completing the squares. Suppose we are given y equals x squared minus 17 over 8x plus 6. Note that in this example, 2a is equal to negative 17 over 8, and this implies that a is equal to negative 17 over 16. A squared is equal to 289 all over 256. We need to add and subtract 289 over 256 on the right-hand side of the equation. Note that x squared minus 17 over 8x plus 289 over 256 is a perfect square, and this can be factored as the quantity x minus 17 over 16 to the second power. So, y equals x squared minus 17 over 8x plus 6 can be written as y equals the quantity x minus 17 over 16 to the second power plus 1,247 all over 256. This equation is in vertex form. Note that A is equal to 1, H is equal to 17 over 16, and K is equal to 1,247 all over 256. The vertex is the point 17 over 16 and 1,247 all over 256. For all the previous examples, we have been dealing with a lead coefficient which is 1. Now, what if the lead coefficient is not equal to 1? Suppose we are given y equals 3x squared plus 2x plus 7. How do we complete the squares? First, factor out the 3 from the entire polynomial so that we can emulate an expression in the form that we used to. We get y equals 3 times the quantity x squared plus 2 over 3x plus 7 over 3. Now, we treat the expression inside the grouping symbol the way we used to when completing the squares. Note that 2a is equal to 2/3. A is equal to 1/3. A squared is equal to 1 over 9. We need to add and subtract 1 over 9 on the right-hand side of the equation. Note that x squared plus 2/3 x plus 1 over 9 is a perfect square, and this can be factored as the quantity x plus 1/3 to the second power. We get the LCD of negative 1 over 9 and 7 over 3, then combine this in one fraction. Recall that the vertex form is given by the equation y equals a times the quantity x minus h to the second power plus k. All that is left is to apply distributive property of multiplication over addition. So, y equals 3x squared plus 2x plus 7 can be written as y equals 3 times the quantity x plus 1/3 to the second power plus 20 over 3. This equation is in vertex form. Note that a is equal to 3, h is equal to negative 1/3, and k is equal to 20 over 3. The vertex is the point negative 1/3 and 20 over 3. If we carefully go over these steps, we can apply completing the squares even when the lead coefficient is not equal to 1. Just remember to start by factoring out the lead coefficient first and then solving everything as you would do normally. Finally, apply distributive property of multiplication over addition to get the vertex form.